Alright, let's take a look at this problem. Example 1b of your Pythagoras Theorem notes. Over here in this problem here, right, we're supposed to solve for b, which is the hypotenuse of the longest side. We already know the formula of Pythagoras Theorem, a squared plus b squared equals c squared. Okay, to solve for b, we'll take a look at the smaller right angle triangle over here. And I can say maybe I let x be the base of the right angled triangle. And now you realize that this x over here, if I'm focusing on what I highlight over here in yellow, this right angle triangle, right, is actually one of the shorter sides. So if I apply the formula that x squared plus 4.8 square equals to 12.4 square, right? Notice that the 12.4 square is the longer side and is alone. And now to solve for x, I rearrange it. And then x is square root of this. Okay, 11.433 cm. Notice that when we want to find the length of the shorter side, over here in the square root, it is a minus. Okay, right, so now we want to find the b, right? Focus on the larger right angle triangle over here. You can say my b is actually square root of 11.433 square plus these two sides here, 4.8 and 7.4. So I can add them up, put a bracket, and then I square it. Then I press the calculator, I'll get 16.719, and I round off to 16.7 cm 3SF. So you notice that for Pythagoras theorem, that when I find the longest side, the hypotenuse, when I do the square root, I apply the Pythagoras theorem, my c is actually square root of a squared plus b squared. But if I want to find one of the shortest sides, I apply the formula, my a is actually square root of the longest side square minus the other shortest side square.